Let us see the next sequential circuit design using a flip-flop called divide by 2 clock divider. So divide by 2 clock, which means if you are giving a 10 MHz as your input, then you will get a 5 MHz as your output. So look at this circuit, a simple clock divider using a flip-flop I have shown here. So in this flip-flop we have a D latch. Initially I am assigning the D as manual assignment. For example, initially we are giving it as 0, then it will be passed to the flip-flop and the complement of the Q output will be assigned back to the D. So now this D acts as a signal, right? So it acts as an intermediate signal. It is neither input nor output because there will be some continuous looping operation will be going to be happen here. Look at the timing diagram. When clear equal to 0, whenever the clock rising edges come, the Q will be triggered, that is the complemented. If it is 0, it is complemented to 1. If it is 1, it is complemented to 0. That's all. So when you design this clock divider, you will get, if you give the input as 10 MHz, your output Q generates 5 MHz. Divide by 2 clock divider. So this is the truth table. So let us have a look at this small design, a simple clock divider using flip-flop. So I take the empty code RTL editor here. So I just take the syntax of complete flip-flop which we already written. I copy and paste the code and I rename the flip-flop into clock divider. So initial stages, these kind of VHDL coding will be tougher, but VHDL acts as one of the robust programming language. So once you start coding, it will become easier. So label the things properly. Divider. So I am naming my block as clock divider, process as clock divider. And as per the given diagram, Q will be knotted and given to D. So which means here we have to make a small change, that intermediate signal should be there, right? Because we can't read the output port. Hence, two things I can do. One, I can declare a new signal, maybe I can name it as temp, standard underscore logic. So I will work with the temp, then I'll assign the value to Q. So temp equal to not of D, but initially we didn't assign D equal to 0. So if you are assigning D equal to 0, that should be here. So now output will be not of D, and now the D value should be temp. Then only it will continuously triggers, and the clock will be rising edge of the clock and behave similar operation, no changes. Now I am running the code for you. I got one error. One error. Cannot drive the input signal mode. Yes, we can't assign it to the input, right? So now I have to make the D as a temporary variable, unless and otherwise if we are making it as not of D and assigning the same to D equal to temp, which means it's similar meaning as this one, right? Temp equal to not of temp. Because as per the design, I am just naming the temporary line as temp, temp equal to not of temp. So this is a closed loop we are going to create. So exactly temp equal to not of temp will be matching. And finally I assign the value to Q. So now it will be working. So D no need to assign because it is a input. And in this case, here instead of temp we can assign D. so that D will be utilized. So guys, work out with this code. So during workout only you will get lots of doubts and errors. So you can contact us anytime for any kind of doubts. Clock clear equal to force to 1. So initially, as per the diagram, I am just making it to 0. So here in this diagram I shown, no, initially D equal to 0. I am making initial value should be 0. So assign to 0. Now slowly run it. Release the clear. This step you should not forget. Unless you didn't release the clear, you won't get the output. Okay, now this clock is being divided by 2. So if you are giving 10 MHz, your output will be 5 MHz. 5 MHz means time period will be increased, frequency will be decreased. So when coming to timing data flow diagram, you can see the output like this. Everything looks like a register because it is a RTL, register transfer logic. So we'll see the next sequential circuit.